Hi, my name is Jim LaBerge, and today I'd like to give you a brief run-through of my new .NET software development productivity tool called .NET Explorer 2023. So here I am on my website. If you click on the download link, if you want to give it a try, come here, and if you're on Windows, I would download the zip, or if you're on Linux, try the tar. Apologize, Mac version isn't ready until I figure out how to sign these things. If you pick these instead of the installer, there's no elevated permissions. And the other thing that I just want to point out while we're here is if you go to the support and getting started, I have a little guide that's a bit more detailed than what I'm going to go through in this video. So for the sake of the video, we're going to try to keep it brief. So I'd like to just bring over a Ubuntu shell that I've got running on Windows Subsystem for Linux. You can see that I've downloaded to a temp directory, a tar file, and you can see the .NET Explorer there. So let's just run it. Okay, so what's going on here? It's obviously a console application. I see localhost, so obviously it's an ASP.NET application. So what you're doing is you're running a web server on your machine. It's going to look like a desktop app. And of course, it's not running with elevated permissions, as I mentioned before. So let's just shut this down. I wanted to show this for the sake of argument. I'm just going to bring over PowerShell on Windows. And now you can see the same thing, but it's got the exe. So I'm running that. Okay, again, it's listed on localhost 5000. Come here, let's jitting. Okay. First thing, we're being challenged for a key, but if you ignore this and just browse, there's a navigation bar here. So the application's broken up into 4 important things. You're going to be spending most of your time in Explorer and sometimes in Assembly. There is a little search option. These are administrative things I'll just glance on briefly. But if I click on the assemblies, you notice that we're in trial mode and there's only one assembly. In trial mode, you'll be limited to angle sharp. It's a very robust application, so you can see that anything that .NET Explorer can do, and this is a fairly heavyweight assembly to analyze. So I'm going to come back and license this guy. You can see it says activated, and now the nag has been replaced with the dashboard. This is more about application health. I won't touch on this here. Let's come back to assemblies. So when you're working with NuGet, you've downloaded a whole bunch of stuff. Often it's things that you've never seen before. So what I'm going to do is I'm going to start collecting things that I have downloaded. So for example, Dapper. Dapper is fairly straightforward and small. But you can see that here is a .NET 4.6. Oops, started to drag and drop. What I should have done is click. So you see it click, it's added. Fluent validation is always interesting. Let's pick a different version. .NET 7 for fun. Just close these for. There's a few things that well, this one doesn't have a lib directory, so that's not what I want. So I'm going to back right up here, and I'm going to go get a great one. And go into MonoCecil from my build environment. Now I'm going to click on Explorer, and when I do that, it's going to save these 4 assemblies. These are things that I want to look at later. Load them and break apart the structure. So if I click on it, it would be very brief. We're going to hop over to the Explorer tab. Here we are on Explorer. This is where you're going to spend most of your time and where most of the rest of the tutorial is going to be. So we've got 4 things. If I start drilling down into MonoCecil, I see a bunch of colored things. So let's drop down this legend accordion. We can see that red is assembly, green is a module, namespace is blue, and then this tealish class will be a class. So if I click on this, I see teal things, I see blue things, which are structures, I see this color, delegates, yet another unnamed color for me are interfaces. So you can sort of see how things, or what it is. You can also hover and get a tooltip. Now, the application is broken up into a left side, which is the structure tree, and the right side over here, which are browsers depending on what you click on. So if you click on a type or an assembly, so red is assembly, any of these others are type. If I click on something, I say I want to explore it, and this side will change to whatever that context is. So the first thing that I want to do, just to keep it simple, is let's go to module definition, which is one of the hard. So MonoCecil is a system.reflection layer that was written by J.B. Avant for MonoCecil. For Mono. So if I click on module definition, which sort of is the analog is system.module, let's see what happens. So we get a couple of browsers. I'll explain that in a second. There's a whole bunch of tabs, and if you don't click on a tab, you don't incur the overhead. These things are load on demand. The first one is always activated. So what do we have here? We have the type emitted to, or what I call emitting, broken down by fields, properties, and constructors. So if I open up the properties to keep the noise down, you can see what's public, you can see the signature, get and set. Things that are red typically are fairly important. Things that are virtual, sealed, abstract, override, that kind of thing. You can control the what is emitted here. I won't go over that, but if you make changes here and then pop up the accordion, this will re-emit and only show you what you asked for. Thing that may show up later is that I've got compiler generated things turned on, and if you want to turn that off, it'll get rid of some of the noise. So this is sort of like the object browser in Visual Studio, if you're familiar with that. But I would like to point out that if you see these blue things, these are types, whether they're in the same assembly or a different assembly. And if you are curious about it, just click on it. Okay. Now, this doesn't change over here, and perhaps it should in the future, but it doesn't. So we've replaced module definition with assembly definition. If you look up here, it says we're on assembly definition now. We were on module definition. And you can keep going that way. So for example, we have these collections and write parameters. So let's try to see what a write parameters is. Okay, you see the breadcrumb trail here. And then let's click on iSymbol provider. So you can jump around very quickly if you want to just hit back, or you can back up, or if you want to go all the way back just to module definition, click there. Okay, so this helps you when you're programming against a third-party library. I've seen with the signature, especially things that are public. Again, if you drop this down and say I only want to see public things, then you would get the interface that you would be programming against. Let's review these two tabs. The first one is just a really high-level overview, not super useful, but it shows you the base classes. So this is derived from module reference, which is derived from object. It implements 4 interfaces. It has some statics, mostly instance field, and then it shows the breakdown of members by how visible. So things that are on the left here are quite visible. Things which are on the left are less visible, and of course protected internal and private protected are a little bit esoteric. I'm clicking on relationships now, and what that's going to do is it's going to take the thing I'm looking at right now, which is module definition right here, and it's going to scan the assembly and say, how is module definition related to the other classes? Okay. I'm going to click on freeze layout and fit. Actually, let's just drag this over here. So this is a network viewer, and this is one of the first ones that I wrote. So it's a little bit old. I intend to upgrade it, but not without consultation with you. So right at the center of the universe is the module definition. And then the squares illustrate what the relationship is, and then the other circles in different colors show the different types that are in that relationship. So let's go over a few. So we already looked at base classes. We know that this should be module reference and system.object. If I come down here to this guy, actually let's ignore parameters for now. These are types that call into module definition. So if I come here and roll the mouse button in, I can see the things that call module definition. I'm going to hit fit again to back out. Thing that module definition calls, it creates these types. It implements these interfaces. I'll just roll in again. So there's 4. So it's iDisposable, super important. And these only have meaning if you're a little bit more familiar with the library. Interesting, it throws these 4 different exceptions. So that's all I want to say about the type browsers. Let's go back here. I'm going to close this up and say I want to analyze the assembly, so all the types as an aggregate and how the types are related to each other. So when I click on that, this browser will be replaced with an assembly Explorer browser. Again, lots of tabs. Some of these are very compute heavy. If you don't click on them, you don't incur the cost. So these are just placeholders. There's nothing behind them. So when I clicked on this, the first one is activated. It's the property. So it's some of the meta information. You can see the custom attributes. The contained modules, of course, pretty much everything only has one module. The dependent assemblies, which can be important when you're programming because sometimes these are missing and you got to go hunting for them, and the contained namespaces. But I've got a better namespace view here. Let's click on this. There's a few more views here. I won't explore them right now. So the way to read this is there's a mono namespace. It has 5 types in it. There's a mono CSL namespace. It has 197 types in it. And then CIL, if you're dealing with IL instructions, so it's mono.csil.cll has 68 types in it. A view that just shows types. This is a common grid control that I use so that it supports the common kind of thing. So right now looks like it's sorted by namespace. This is every type in the assembly list, so 25 times that is the number of types. If I click on the kind, you can see that I've got a mix of different kinds. We'll sort. If I click on again, inverse sort. So if you're interested, for example, to see if something has operators, click on it twice. In this case, no. Clicked on that twice. There's only one thing that has an event, and that is the base assembly resolver. All right. So sure, that's just a list of types. Which types? Oh, sorry. Let me close this. Which types are simple or trivial, and which types are complex? Let's ask that question. So we'll click on this guy. So this is a multi-dimensional view of all the types. So if we look at the horizontal axis, it's the field count or the data complexity. And if we look at the vertical axis, it's the method count, or perhaps you could argue computational complexity. Now, of course, if these are just getters that are returning a vacuum field, they're not complex. So the next dimension is the circle size, which if you look at the tooltip, the thing at the top is monoCCL, the namespace. Metadata builder is the type. And if you look at the IL instructions, it's almost 4,000 IL instructions. So the way to read this is that as you go from here, you have the most trivial. So opcode names is the most trivial. And by some definitions, the most complex class is the metadata builder. It has a large number of fields, large number of methods, and large IL count. Now it's interesting, if you come down here, you only have 6 methods, but the IL count. Now I would argue that perhaps the scaling needs to be improved, because that's 4,000 and that's 1,000, but it does show that some of these things which are down here in low field count or member counts can have a large number of IL. And the last thing, element of or dimension on here is color. So look at the top, monoCCL namespace, green, monoCCL PE, metadata, and then mono. Okay, before I click on these are all interrelated. They're computationally complex, so please be patient, because of course we're running a web browser. In the back end is a C# ASP.NET server. The calls are asynchronous, so if you sit here and click on things, you're not going to improve your lot in life, sorry. So I'll just click on this and then I'll explain what's come up here. So I've gone through the entire assembly and I said, how are things derived from each other? I can see that it's kind of struggling with this cloud. I'm just going to drag this over here and then hit fit and freeze. So here's system.object. We know that everything that's not an interface has to be derived directly or indirectly from system.object. Here are the things, simple things, which are derived from there. And you can see the line in. So for example, if I click type reference protection, and it's sealed, okay? No, most of these do not participate in further derivation, but obviously as you start moving out this way, you start to see a derivation chain. So we have an abstract metadata table. Obviously, if it's abstract, you want to derive something from that. Here's something big. Another abstract metadata table with a T row. And then one more, a sorted table, and then we have concrete implementations. With this network browser, again, if something interests you, you can roll in. So for example, what is this weird looking thing? So I'm going to roll in. It's got a different shape. So I'm going to come here and click on the legend because it explains shapes. So the shapes thing here, this is an interface, okay? So, enumerations sort of look like a list. Delegates look like f of x. And then because structures and classes are most of the things, I kept it simple. Class is just a circle. If it's a generic class, you know, it's sort of like the circle. A circle can take on more shapes. If it's sealed, you know, it's got protection, you know, someone's trying to derive from above. No, that can't happen. A static class is a little bit more ephemeral, so I draw this. And of course, we can have generic structures. The other thing I want to point out, just coming back here, and I'll click on fit again, is that for the most part, things are gold, which are inside CCL, and then some things are blue. If we come back, that's this coloring. Oh, sorry, no. This coloring here. Blue is external and gold is internal. There are other ways of coloring the assemblies, which I won't go into, but if you were to color it, the network would become much more colorful. All right, so let's click on the next tab, composition. I'll let it lay out just for a second. Sometimes this can be fascinating and then you'll get bored of it quickly. Clicking on freeze and then fit. So to explain this, let's just take a simple contrived example. For example, customer orders products. So if you were looking at that, you would expect to see a products node that was related to one customer node and several, sorry, did I say that right? One order node connected to one customer node and the order node to many products nodes. Now, the order might contain order ID and date, but for the purposes of a gross view of the entire assembly, we don't care about scalars. We don't care about booleans, date times, strings, enums, that kind of thing. It's only where a type has a reference type to another thing. So we can see that there's gold again, which is in CSAL, blue, which is not in CSAL, and now we see some red things, which are just collectors that I've created that kind of point out things of interest. So these are things that aren't composed anywhere. So either they're unused, or to use them, you need to do new. Either CSAL needs to do new, or if you're the one using CSAL, you need to do new. All of these things that are connected here, if I click on it, it doesn't. I was hoping the edges would show up a little bit better. But if you look at anything that's connected to this, they're self-referential. Often that's either a linked list or a hierarchy. And then these are things that are high level, so they're composed of other types, but no other type is composed of them. And then finally static types, and of course you can't compose static types. If you hover on the tooltip, it shows you, for example, that in this direction from this class contains two instances of this. We can see a few thick lines, 219 instances, and I apologize, that's supposed to be a new line, the HTML entity that you see. So this is 219 instances and two arrays, 18 instances, for example. So you can glean a lot of information. The size of the node is proportionate to the number of outgoing edges by default. So size matters, and you can see, which types are more. There's a whole lot more going on here, which I will show in another video. So I've done hierarchy and composition, and I've shown you the legend so far. I'll click on creation and leave calls for last, because both of these require going through the instruction set of an assembly, and creation is going to be bigger yet, and calls is going to be the biggest network or graph of all of them. So this is a view of which types create another type, and you can see that compared to composition, it's busier, and in my experience it's almost always a larger graph. If I look at the node and edge count here, 259 nodes and 481 edges, and come back, quite a bit more. So there's more there's more relationships going on, and of course we know that creation is a form of coupling, although I'm not doing anything to recognize dependency injection or dependency inversion right now. That might be something to consider in the future. Again, collector nodes, things that are only created by self, not created. Abstract types, so of course you can't call new on them. And static types. Again, size matters. So the last thing that I want to do for the networks today is click on calls. So while that text was there, it was C# doing computation. Once it disappears, it's been handed back to JavaScript, and the JavaScript engine is trying to lay it out. The engine is O(n) squared, so as the edge count, which doesn't show up until I click freeze, I'm going to click freeze and then fit. Again, higher number. So it's n squared, so almost 2 million on this, whereas when it was 100, that's 10,000. So the larger the network, the harder it is for JavaScript to lay it out. A lot of the usual things apply. I do want to point out that by and large on all of these networks, regardless of what you're looking at, things that are lesser important tend to be on the periphery. Things that are important tend to, because of the physics engine, be pulled to the center. So when you're doing an analysis, that size is one indicator. If it's on the outside, it's probably a low-level class. So it's being called and it's not calling anything. And you can see the workhorses in here because they tend to be larger and have large amount of connectivity. Just so you can sort of see what I'm talking about, if I click on this color by, right now it's got the internal. If I click on namespace, you can see it's changed to coloring by namespace and then by assembly. And again, if you want the meaning, you have to come back to this, although the tooltips tend to tell you. Okay, that's it for the network browsers. The last thing I want to show you is the search. So I'm going to click on here and then click on here. So I've written a small formal language in a compiler generator called Coco/R. And so when you do a search, you give it the context. And so instead of the object browser, for example, in Visual Studio, if you just say count, it'll find you types name count, fields name count, count somewhere in the method name. You get a lot of noise, so you have to filter through this. So instead, I've got keywords here, and this is to serve as an example. For example, if you want something that is a type whose suffix is attribute, which is obviously going to be a custom attribute, you would type in name asterisk attribute. If you were interested in something that implemented an interface, I put enumerable here, but quite often that's interesting is iDisposable, and I'll actually show you that. Show me types that are in the namespace, that have a field name something, have a property name something. And again, you can use these wildcard searches. It's immediate base class. Perhaps it derives from, directly or indirectly, from a class. And you can also use Boolean operators and or. And the last thing that's here I've added just recently is adding LINQ expressions. Very powerful because you can pretty much do anything with it. The problem is that you need to know mono-CSOL, and until I get that documented properly, this would probably be a little bit more difficult because, of course, it's not system.reflection, but it sort of looks like system.reflection. So let's come in here and let's try a search. So with those things that I typed in, let's see if anything is an attribute. Nope, nothing's an attribute. How about implements iDisposable? Okay, quite a bit. Again, as always, you can sort this thing so it's by name here, but we could click it by namespace. So to show off the Boolean thing, so I said iDisposable. Let's say we also want it to be in all right, there you go. So that's it for today. That was a very high level overview that you can see how or what kind of explorations that you can do on .NET. Again, if you're playing with it, please come to the contact page and send me some feedback. Hope you enjoy. Thank you.